Okay. So going back to this one. All right, so the question is, how many of these 202s do I have? Well, that's where that general formula comes in. That the nth term equals the first term plus n minus 1 times the common difference. In this case, I'm looking at the 51 to 151. And I want to figure out how many terms did I take to get to the 151. So I stopped at 151. The first number of the pattern was 51. The n is what I'm trying to solve for. And then as far as the common difference goes, that one I just look back at the original pattern, and if I went from 51 to 52 to 53, how far did I go each time?
Well, you went by 1?
By 1. Okay, so that common difference for this pattern is 1. And then I just solve for n in this case. So take off the 51. So that puts me at 100 equals. Then if I multiply that out, I get n minus 1. So bring the 1 over. 101 equals n. So that means in this particular pattern, there's 101 numbers. So when I come up here and I say that I have 202 the whole time, well, how many 202s do I have? I have 101. So if I want to add that all up, I have 101 times the 202. But if we remember, I took the same list of numbers and I added it twice. So I want to take that and divide by 2. So if I type that in a calculator, that should tell me what it all adds up to, and that would be 10,201. So you're going to see something like that. Exact same pattern. Any question on that one?
No, I think I got that one.
Okay.
So the n is the number of 202s, right?
N is how many 202s did we have?
Okay.
And it's the same number as if I start at 51 and end at 151, how many numbers in a row am I adding?
Oh, okay. But since we did it like forwards and backwards, it's 202.
Right. Anything else on that?
No.
Okay. Anything about counterexamples, or how many different ways can you make change?
Just like the vocabulary for that, the counterexamples, like, because there's a lot, right?
Oh yeah. There's a ton of good counterexamples. What usually gets students caught off guard is when they're not sure if they should be adding, subtracting, multiplying, or dividing. Or they pick numbers that like this statement says if 2 even numbers are added. So they need to pick 2 even numbers, like 2 and 4, 6 and 8. Like, those are even. So I've seen students that just pick like 3 and 5, and I'm like, okay, those aren't even the right numbers. You obviously don't know what you're doing on this one. So as long as you pick 2 even numbers, and then just show me that when you add them up, they either end up with an even number every time or an odd number, and then that's your counterexample.
That vocabulary was from which chapter?
The first one.
The first one? But is it like from 1? Is it 1, 2?
We do counterexample the whole class. So I could tell you it's 1, 1 and 1, 2, and I mean, the idea of something that proves something wrong comes up pretty much every test. So.
Okay, so on these type of problems, all you want us to do is write what you're telling us pretty much, and then tell you if it's true or not.
Right.
And so counterexample is just there?
A counterexample is an example that disproves something.
Yes, sir.
So if I say I'm going to flip a coin and it's going to land on heads every time, then all you got to do is, I'm going to, and you take out a coin and flip it and it lands on tails. You're like, here's tails. It didn't work. Your rule didn't work every time. All you need is one situation where the rule doesn't work. Then that would be an appropriate counterexample.
Okay.
So again, I wouldn't stress too much about that particular one. I'm not trying to scare anyone with the vocab, but anyways. Do you know what to do with how many different ways can you make change?
Yes, sir. I think I do.
Got that one? Okay. How are we on our magic squares?
I think, I don't know. It's because since I did this homework first, I did it like last week.
Okay.
So like everything in my mind is like race.
Jumbled.
Yeah.
Yeah. Well, if it makes you feel better, if you want to take one of your tests before the other one, like I'll be there. Oh goodness, I'll be there all day. So if you want to come to my office and like I've got students that are taking makeup exams in and out the whole day tomorrow. So if you just want to email me and set up a time, then you're more than welcome to come in and take one of them early.
That would be better because that way I can just go to. Yeah, I think that'll be better. Just so I can just so I don't get them confused. Like I don't know.
I mean they're totally different subjects, so I wouldn't. I know right now you're just nervous because you've never taken one of my tests before, but it's like this magic square question. If you've done it and it's worked, then you know what you're doing, and I would just make sure you practice on one, just get the general idea down.
Okay. Do we have time to do this one, or is it kind of long? Because I can just watch the video on it.
Yeah, you're more than welcome to do that. Yeah, we can start it. Mm-hmm. So the idea is you want to add up all the numbers and then figure out what the magic is supposed to be. So I would take out a calculator and do that real quick. 10 plus 11 plus 12 plus 13, 15, 16, 17, and 18. Okay, so I got that if you add them all up, you get 126. And then do you know what we do with that number?
Sir?
Do you know what you do with the 126?
No. Oh, you divide it by the number of squares?
Not the number of squares, but the number of squares that I want to add up to the same thing. Does that make sense?
Yeah, so it would be 9, right?
3.
3?
Yep.
Oh, yeah, because you... Okay, I get it.
Because 3 numbers are going to make up the magic sum.
Yes, sir.
Okay, so that means I got to get 42. And then one of these numbers is in the dead center. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. All right, so this 14 is in the middle. So that means 14 is going to have the most pairs. So I can already come in here and I can just put 14 in the center. And then it's just going through and recognizing, well, what, 13 plus 14 plus 15 gives us 42. So that's a pair. And if I go one more out, so 12, 14, and 16 adds up to 42. And 11, 14, and 17 add up to, you see, I'm just going one out each time. Mm-hmm. And then 10, 14, and 18 also give us our magic number. Okay, so now I've got 4 different combinations. And in class, I said, well, either like this 13, 14, 15, it's either going to go vertically or horizontally, or it's going to go diagonally. So I said, let's just guess one of the directions. And then let's take another combination. So 10, 14, 18. And I would say, let's try that diagonally. And then let's see if it works. So if this works, then if I fill in the missing numbers, I should be able to get the 42 pretty quick. So like 42, that 10 and 13 have to have a 19 there. So 19 is outside of our list. So I can't put the 10 where I put it, but maybe I can put the 10 over here, put the 18 over there. Does that make sense?
Yes, sir.
Okay. So then I'm going to go, well, let's try 13 and 18. And so that's got to be 11. Okay, so that's on my list. So 11, 14, 17. So is 10 plus 15 plus 17 is at 42, and that actually is. So we might have just lucked into this. Except this one right here, 42 and 18. 18 and 17 can't be across from each other. But if I can move that down there, let's see. Anyways, so you can't. I'll kind of at this point you can kind of watch the video, but you kind of move around numbers until you find the right combination that works. And if you can't get it to work, then maybe my 13-15 combo shouldn't have gone there. Maybe they should have gone this way, or maybe I should have put them diagonally. So I just kind of rotate them around until I find a good spot that they'll work. And it's meant to be a little frustrating. So it's meant to, you're not supposed to get it right the first time. It's the whole idea of a magic square is to demonstrate problem solving and kind of show that if you do get stuck, there is a light at the end of the tunnel.
Oh, okay.
So, anyways, you good? You want more of this? You good on this one, or?
Yeah, I think I'm good on that one.
Okay. Dun, 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 dun. Okay, another problem-solving one. Or you're just playing with patterns. Another play with patterns.
Is that one the? Sir?
Which one? You want the points or the boxes?
Whichever.
Okay.
Yes, sir.
Juan's team entered a math contest where teams compete by answering questions that are either worth 3 or 5. No partial was given. Juan scored 44 points on 12 questions. How many 5-point questions did he get correct? Answer correctly. Okay. So I want to make a little table here. And I say a total of 44. And then I'm going to go 5 points and 3 points. Okay, so then I'm going to just do problem solving. So what's the most number of 5-point questions that he can get right? The most would be 8, right? Except if I go 8 times 5, that's 40. So the other, there's no way 3 points will ever get that done. So 8 isn't the biggest. So 7. So it's 7. Yes. Where we got 44. 7 times 5, which is 35, like, right?
You can. It's like cutting off.
Yeah. Oh, my sound?
Yes, sir.
That's just how I talk all the time.
Oh.
Okay. So on this, I might have to switch. You know what? I want to check real quick. I don't think anyone else shown up? Oh, Anna here, who is being real quiet. Blah. Okay. Yeah, usually if other people start showing up, that's when the sound starts acting weird.
Oh.
So it's not a terrible thing. Okay, anyways. So
I try to cut off my sound because there's a lot going on in the background.
I understand.
But I'm listening.
I've hidden myself away from my family. Okay. If we go 7 5-pointers, that would leave me with 9 points, which 3 3-point questions would be enough. But does this combination add up to 12 questions?
No.
So we got 7 and 3. Okay, so I know that's not the right combination, but that's the largest number of 5-point questions is 7. So then I go down to 6 and think, okay, can I get the right combination from that? So if I go 44 minus 5 times 6, which is 14. So is there any way I can get 3-pointers to give me that?
It would be, let me see. Wouldn't it be?
So with 6 questions, there's no combination of 3 that'll work.
Okay.
So I'm going to jump down to 5. And at that point, let's see, I get 19, which that's not going to work. So we're going to go down to 4. All right, so that gives me 24. And so there is a combination of 3. There's 8 of those. And so at this point, does this add up to 12?
Yes, sir.
Yep. Okay. So how many 5-point questions are there? There are 4 of them. Yay. All right, anything else on that one?
No, sir.
Okay. My box has disappeared. Do you want to talk about the box pattern, or you want to go down to set stuff?
Isn't that the same like the other one that we did, or the other one that we skipped? Like at the very beginning, where you have to find like the missing numbers?
Yep, pretty much. But this involves pictures, so it's a different way to communicate the information, but it's exact same idea.
So you would still use one of the formulas, right?
Yep.
Okay.
So I have 8 white squares in the first pattern. What is this? 4, 8. Oh, 12. So 12 for the next pattern. And then 5, 16. Okay, so then I stop and go, hey, what do I notice? I noticed that they're all going up by 4. So it's an arrow pattern that is that general formula. We got another person showing up. Oh, nope, just two of us. Okay. Oh, that's got to be scary to see that. Anyways, anything else about 7? We feel good?
Yeah. So you don't have to count the ones, the things in blue?
That's just a different pattern. So
Oh,
that
okay.
would be 1, 4, 9. And then in that case, we go, hey, those are perfect squares. So from here, I could just keep going, 16, 25. So by the 10th picture, it'd be 10 squared or 100. But that's the general idea.
Yes, sir.
All right, you want to jump down to sets? Yay. All right, what do you want to talk about here?
For me, it's confusing when they give you a picture and they ask you to draw like the diagram, or they give you a diagram and they're like, give us the set for this.
Oh, gotcha.
Like the Venn diagrams.
Yeah.
So
Like the shaded, the ones in the back page, the very back page.
They're like shaded. I think it's called like the proper subset.
Yeah, number 20 was a little confusing.
Okay. Of course, you guys picked the question that's really hard to do with a mouse. Okay. So let me think. I want to do this. I can draw something. We'll do that. Okay. So right here where it says Z bar on that. What is Z bar saying?
Not in Z.
Not in Z. Okay. So I look where Z is, and I look outside of it. You know, it's the outside piece that we're thinking about, and we're intersecting that with Y. So I need to look outside where it's crossing with Y. So that's thought I had a way I was going to be happy with this, but so it's this chunk. So like from right here all the way down to here.
How do you know with which set to start so you don't get confused?
It's like order of ops. Go into the innermost piece. Parentheses.
So like parentheses first?
Yeah. So I would start with this Y intersect complement of Z, and I'd figure out what part of the picture that's supposed to get me to look at. So that's this moon-looking shape. I don't know if y'all can see my mouse moving here, but that shape right there looks like a moon.
Mm-hmm.
And then they want to union that with set X. So now it's everything in X. So now we actually bring X back in, all of X. But then we add this little crescent piece right here on top of it. So the only thing that really isn't shaded is the outside stuff. And then, and you know what? I have a video of this. I can just pull that up and just point to that. I I'm working way too hard for this. Yeah, so right, oh, I just had it up a second ago. So that, the yellow piece. I got close with my mouse. That's what I was trying to highlight. Ah. All right, what else you want to talk about?
Will you have the truth tables on the test?
Yep.
Okay.
And it's kind of the same one we did in class, where it starts off, it's a big brick of it, but it's like the last one looks really scary, but if you do the pieces before it, it's just taking the two pieces before it and putting them together.
What about the ones that are like that you have to negate, like the quantifier, universal?
You know,
Kind of like what she said, the truth and false tables. Like,
yeah, so the truth table stuff, that's on there, but the verbal stuff where you know, some people like ice cream, all people enjoy going to the movies, like those statements, I've decided I'm going to kick off the test this semester and see how I like it. So I normally have that stuff on my test, and this semester I went, we'll try something else.
oh, so like the all and the sum and there exist.
Right. So those you did on the homework, and I feel like that's enough. I feel like I don't need to drill it down and.
What about the converse, inverse, and contra?
Contrapositives. I will give you a sentence and have you write the three other if-thens about it.
Okay.
But it's just a textbook. Write the converse, inverse, contrapositive. You're not doing anything else with it other than just demonstrating that you can manipulate a sentence.
Okay, and on one of the homework questions, it gave you like, it was like, it switched the order, but it had not in it, and the correct answer was like without switching the letters, like Q and P, those two on the sentence, like whatever Q stood for, it switched. Do I make any sense? I don't know if I'm making any sense.
Yeah. No,
okay,
on
so
homework, they'll mess with you and they'll switch the order up on you.
So just if they switch the if they switch the order, then you switch the letters, correct?
Right.
Okay.
But I'm throwing a textbook. If I'm happy, then you know it. Like it's straight up if then, nothing clever about it. Just making sure we can understand the vocabulary and rewrite things in an order that makes sense.
So then, like law of detachment and valid reasoning, that's gonna be on it too.
Not. You're asking things I wish I'd put on there, man. Okay.
Oh
no. No, I'm not going to ask. I mean, I'll ask you if it's valid or not. So I will give you a statement and ask you, is this a valid conclusion? But I'm not going to make you tell me whether it's a law of detachment or law of converse or any of the logic theory stuff. About as far as I'll get is using sets to identify elements of sets. So this terminology here with union, intersection, difference, that sort of thing.
So kind of like focus on that.
Yeah, I would say focus more on understanding the set and set elements and really about the symbols. So like proper subset versus subset, cross product, stuff like that.
Are you gonna have on the homework, the 2.1 through 2.3 practice? There's a question on there that has the Venn diagrams, and you're supposed to write the set notation. Are you gonna have that too?
So I will give you kind of like number 19, where I give you symbols and you sketch a picture from it.
Okay, so just the picture.
Yeah.
But not the other way around.
I'm trying to think. No, I don't think I have it on there. The one that we did in class, there was multiple right answers. So I tend to shy away from things that make me think too hard when I'm grading.
Okay.
So for the sets, we just have to draw the picture.
Yeah, shade in.
Yeah.
Yeah.
Okay,
Yeah,
so
there-
what
yeah.
is what we Sir?
Like, go ahead. One more time, Esmeralda.
Oh no, I was wondering what is the that you shade? If I'm making, I don't know. I don't know. I think I'm just like overthinking everything.
So there's a link in the test review folder that I have hanging out there on Venn diagrams specifically. It says practice on Venn diagrams. So I would go through this Quizlet and just make sure you can read the information and identify like which part of the graph it's trying to get you to look at, if that makes sense. So like I don't know if you guys can see this big enough, but I'll describe a set and I'll just ask you, what region am I talking about when I describe this? So if I, like in this case, theater, but not band or choir. So in which case I'd be talking about
7.
So stuff like that. So I thought this was a good Quizlet set. Actually, I think I made this. Long time ago. Anyways. All right. What else are we nervous about?
Are you gonna have something like on lessons, on the practice lesson for 1.1 and 1.2, number 7? There's it says each of the following sequences is either arithmetic or geometric. Identify the sequences and list the next 3 terms for each. And then the very last one, it's 193 plus 7 times 2 with a 30 over the 2.
Oh, exponents and fractions on drugs. No. I'm gonna throw really simple number patterns at you.
Okay, thank you. That one makes me nervous.
We we build up to the more unpleasant looking numbers throughout the course. So I'm not too keen on throwing something nasty at you right at the beginning. I want a couple of months to at least build your confidence up before I start crushing it like that.
Okay.
What other kind of word problems would you suggest us studying?
Well, that's a good question. So the ones on the practice test are I promise you're going to see stuff like that. So stuff like number 4, where you want to make a table to organize your thinking. Stuff like the point question, that's a good one. What else? But a lot of the problem solving stuff, Like those are set methods that I want to make sure that we can do. But the other questions that I'm going to throw at you are really just designed to just surprise you. Like I'm going to throw something weird at you. Just prepare it. Like just mentally tell yourself, he's going to throw something odd. He's going to make me think, and that's okay. The whole lesson, or one of the lessons we looked at, were problem-solving techniques. So I got to throw something that you've never seen before just to see how you handle yourself when you have to really problem solve. So there's a couple of patterns that, like setting up a chart or setting up a Venn diagram, and organizing your information that way. Like those would be givens. You're going to see stuff like that. But on the same note, like you can't prepare for everything. So just take a deep breath. Okay. It's probably not what you want to hear, but that's what I'm going to tell you.
I don't know. I feel like I don't like.
You're just forcibly flipping through those pages, like just.
Yeah, because like I don't know what to like study over. Like I'm gonna do the review, but I don't know if like I need to study vocabulary or like go over like just do the review and then go over again all my notes. Like I don't know if.
So I would start with the practice test. Make sure you're solid on that. I will claim fairly confidently that if you can handle the practice test without any help, that you got all those ideas down, you can at least pass the test. Pretty confident that's then what you want to do is you want to go back through your notes and ask, what didn't he ask on this practice test? Is it like did he skip like fringe topic that only showed up in one situation, or are there other ideas that we've practiced a lot, but maybe you didn't feel like we had to stick on a practice test?
So like the truth tables.
Yeah, like the truth table.
Will you have many of those on the test?
Just one.
Okay.
But it's got lots of columns.
Okay.
But yeah, no, it's I try not to surprise you guys too much.
Did you talk about set builder notation?
What am I messing up?
Oh, set builder notation? Do we have
set builder? We talked about it. All set builder is you put the fancy brackets around like right here. Is you put these fancy brackets around the letters, and you're just telling me what things are inside the fancy brackets.
Okay.
Anything else we're nervous about? Oh, I don't think Anna was here when I showed this. I am going to give you those two formulas on the test.
They're going to be, they're already going to be on there?
They're already on there. Yeah.
Awesome. Thank you.
You're welcome.
I'm okay with the first one, but the second one, no.
Well, if it makes you feel any better, I give you the formula, but I highly doubt you use it.
Yeah, because for the squares, on the review, the first, second, and third that you had to figure out the number for 10. I just did it I just counted 4 until I got to 44.
What? Well, that's nice and convenient. There's an easy way to fix that.
Yeah.
You just ask for the 50th one.
Yeah, once I applied the formula like you showed on your video, it was easier.
Yeah. So if it was me, I'd print out the practice test, go through it, check the answers from the solutions, and if I got it, I would go sleep over this.
Like the review you said, or there's a practice test.
Well, review, practice, test, whatever.
Oh, okay.
Whatever you want to call that magic document I threw at you. All right. Anything else you guys want to chat about?
No.
Otherwise, I have
I think you have a class in 5 minutes.
Well, I have another test review.
Oh, okay. Just on the, I think you went over that. The students that like biology and all that. We just start from the end of the sentence.
Yes. Start with the
Okay.
Sorry.
I think I'm good. I just gotta go over the review one last time.
Yeah. You'll do fine.
Thank you.
No problem. All right, I will. I'll be on campus. I don't know. I got to eat at some point. I have a meeting like at 4 to 5 or something. But the rest of the time I'm on campus. So if you guys think of other questions, just email me.
Okay.
Okay.
Thank you so much.
Yes,
All
sir.
right.
Thank you.
Give me about 5 minutes. I'm gonna get my other one started. So I'll send that link out in other class. All right.
Okay. Have a good night.
Yep. You too.
Yes,
Thank you.
yes, sir.